Hello, everyone. I'd like to begin by welcoming all of our followers to our YouTube program featuring the Power Grid. As a part of the 2021 IEEE PES GT&D Istanbul Conference and Exhibition, we'll be sharing a comprehensive set of videos with you in which we'll be discussing the future of the energy sector on a different perspective with distinguished guests from both the field and the academia. I'm Assistant Professor Lale Erdem Atılgan from Istanbul Technical University, and today I'll be hosting Electrical and Computer Engineering Professor Saifur Rahman to share his valuable expertise with us. Professor Rahman will be talking about an emerging technology for IoT applications in the smart grid today. Professor Rahman, welcome to our YouTube project, and thank you very much for your collaboration with us. And before I leave the floor to you, I'd like to introduce you in more detail. Professor Rahman is the founding director of the Advanced Research Institute of Virginia Tech University, where he is the Joseph R. Loring Professor of Electrical and Computer Engineering. Undertaking many different roles in IEEE, he is a Life Fellow and an IEEE Millennium Medal winner, and has served as the president of the IEEE Power and Energy Society for 2018 and 19. He has published over 140 journal papers and has made over 400 conference and invited presentations. He's a distinguished lecturer for the IEEE Power and Energy Society and has lectured on renewable energy, energy efficiency, smart grids, energy internet, blockchain, IoT sensor integration, and many more topics in over 30 countries. So we're very, very happy to have Professor Rahman with us today. I would like to say welcome once again and leave the floor to you to give your remarks on the topic of emerging technology for IoT applications in the smart grid.
Thank you very much, Della. I appreciate the kind introduction. And all my friends all over Turkey, Europe, US, Asia, Middle East, I have been to many of those countries. I'm very pleased to be able to come in front of you today and talk about the big conference that Leila just mentioned. We'll talk about that more later on. But what I believe are the technologies that will be highlighted in this conference, which I hope will attract you to join this conference if you can later on in 2021. So the two items here we're focusing on, one is IoT and smart grid. These are abstract terms. What is IoT? Well, Internet of Things. What does it mean? Well, we don't know. We'll figure out. What is smart grid? People talk about smart grid in different contexts. So I'll give you my understanding. I'm doing a smart grid for last 8 years now. I started a long time back. So to me, smart grid is an ecosystem, not just one network, ecosystem. Why is that? Because we want to make the world smarter, make the world more livable and more sustainable. Very important, sustainability. We all talk about global warming, climate change, CO2 emissions. How does smart grid help us to do the right things? Very important. As you know, Turkey is a good example. So is Europe, America, China, India, focusing heavily on renewable energy. What is the connection between renewable energy and smart grid? Very important connection. As these things become more dependent on renewables, mainly wind and solar, things become more intermittent. I cannot guarantee Istanbul will have rain tomorrow or no rain tomorrow. You cannot guarantee that. You cannot guarantee you'll have sunlight all day tomorrow. You cannot guarantee that. But you can have technology, science to help you to adjust to changing situations. That's to me smart grid. Smart grid is smart, intelligent, so that it can figure out what to do based on what is happening around it. That's to me is the first definition of smart grid. IoT is the Internet of Things. We all know what internet is. What is IoT? I'll give you some example. I have done this research in my lab. How do I use smart technology to understand what's happening inside the building, outside the building? Based on that information that I'm sensing using my smart sensors, I can take actions. And those actions will make the building more livable. If you have a building that is too hot or too cold, it's not comfortable. Today, we talk about issues dealing with COVID-19, issue of virus inside the building. If we have the right sensor for virus detection, I can make the building more healthy by releasing other products to clean the virus. So I want you to think in a comprehensive way, not just electrical engineering. We are human beings first. So I like to leave that idea now for Leila to pursue further. But this is what I believe in my own life. I have said to my students, human beings come first, then comes technology, not the other way around. So let's focus on that and move on. Leila, I'm ready for your questions.
Exactly. So you said that when you mentioned smart grids, you're talking or you're thinking about an ecosystem. So could you give us your own definition of a smart grid ecosystem?
Yeah, thank you. If I'm smart in various ways, not me, the system. We have smart buildings. I talk about that in a minute. We have a smart campus, could be an ITU campus. We have a smart city, could be Istanbul, and smart grid. Hierarchy. My point is, you cannot have a smart grid unless you have components of the smart grid that are smart. What is the component? Smart city is a component. Many, like a power company in Turkey or in Europe, anywhere, they have many cities they manage. You cannot have a smart grid unless your city is smart. What is a smart city? Smart city doesn't mean smart buildings. What's a smart building? Building is a building. What is smart? Building is not just bricks and steel and concrete. It is people living in the building. As we build a building, we put an infrastructure in the building, which is lighting control, heating, cooling control, ventilation control, all of that things go on. That is the smartness. So we want to make the building a living being, not just a brick and mortar and steel and concrete. It lives, it does things based on surrounding conditions. That's a smart building. You have a smart city. If a smart campus, could be university campus, could be research company complex, could be a huge shopping center. That's a smart campus. All things are smart. Then I have a smart city. Could be Istanbul, could be London, Paris, New York, doesn't matter. The smart city must have smart buildings. And then power company on the top sitting there, it is now looking at the smart city to control it so that it is convenient, it is clean, it is safe, it is sustainable. That's the hierarchy. Smart grid, smart city, smart campus, smart building.
Thank you very much. So I believe at Virginia Tech, you're using a specific platform called the Wise Building Platform, which is compatible with different protocols. And could you tell us a little bit about this platform and which protocols that you're working with in this platform?
Right. Very good point. First of all, what is wise building? I made the term up. I make a building wise. Wise means you are thinking. So how is building wise? What is a wise person? The wise person don't talk much. He or she
better than a smart person.
He or she looks around and listens to people, thinking what they're saying. After he or she has figured out what they've said, then he opens his mouth and do this. Exactly this. Wise building is quietly sensing in the building how many people, what is the temperature, what's the humidity, what's the noise, what is CO2 concentration. It's called sensing first. Once it senses, it has an algorithm. If I have too much CO2 in the building, I'll throw more fresh air. That's the action. So one is called sensing, second called control. So my wise building platform can do both. That's a wise. It listens, monitors, measures the situation, then take action based on what is good for the building. That's the wise definition. You talk about protocols. You're right. If you have many IoT devices, thermostat, light switch, smart plug, ventilation control, all of those are smart devices. We are a university. We don't make things. We don't build things. We are not a company. We buy things from the open market, literally. In my lab stuff, I have all bought from different places. I have no control over a manufacturer, what protocol they use to collect information. I have no control. I know that it could be Zigbee, Wi-Fi, Ethernet, many different things. So our wise building platform is smart enough to figure out whatever the protocol is, it can sense the information. Protocol independent. Give me any device, I can get any protocol, I can talk to it. So that's the issue of protocol independence.
So when we're talking about Internet of Things, about all of these platforms working over the internet, all of this communication of different devices, we always have a question mark in our heads about data security. So specifically on this platform or with IoT applications that you're working on, how do you manage data security?
Very good. Our wise building platform can function in two different layers. One is inside the building, within the building. You can only sense and control if you are in the building. Cannot do remote. That's one. We call local platform. If it is local platform, then nobody can come in and check what's going on. You're inside the building. So you be physically inside the building to do this. That's not difficult to do. But if you depend on being present inside the building, you're limited in your capacity to control many things. You cannot. You go, IT has 50 buildings, 50 people sitting in 50 buildings, and things doesn't work very well. So we have moved to the cloud. Right now, our algorithm lives in the cloud, and we monitor and send data to the cloud all the time and get instructions from the cloud to do this. The reason I do this, if I put my algorithm in the building, somebody comes in, physically computer is damaged, I'm stuck. Even the cloud, they cannot get there. But you're right, security comes in. What we do to secure any information we send is encrypted. 128 to 56 level encryption, it goes encrypted. So you can look at my traffic, you can see data going through, you can tell what it is, just see the data going through. It's encrypted because of that reason. You cannot inject any noise. It's encrypted. Once it goes to my algorithm in the cloud, then decrypted internally. Then takes an action and sends command back, also encrypted. And my device, which is good with thermostat, lighting controller, can decrypt that information and do this. You could ask what happens if the line is broken. Possible, right? Can break. The way we designed the system is we store current condition in the device itself. So if you break the line, it would keep on working. That it is programmed already, but it cannot change. That's the difference. You cannot change it. It'll work. Lights will not go on. They'll stay on, but you cannot turn them off remotely. How we deal with the situation of encryption and somebody hacking it and creating noise in the system.
Another question I have in mind is actually right after you said human beings come before technology. We know that research shows that user satisfaction is a major influencer of the acceptance of smart systems, especially for interior comfort conditions for buildings. I believe in your WISE building platform, you're using machine learning algorithms to draw insights from a deployed building's historical operating data and also occupant preferences for energy savings. And of course, increasing occupant comfort as well. So I've seen on your website that there has been some applications that you already worked with several buildings with the WISE building platform. And have you had a chance to conduct any post-occupancy evaluations, or if you are applying this platform onto a new building, which has no pre-occupancy data available, how do you proceed with these new buildings?
Well, let me answer the first question first, how machine learning is used. That's a good question. For example, we watch people's behavior in the building as a function of existing ambient conditions, temperature, humidity, primarily these two. What we do, we did literally did this in an experiment. We have a building remotely being monitored. The building has staff, it has students, teachers, all that. We raise the temperature by 1 degree centigrade and see how they react. If they don't react, that means they're okay. If they react, means they'll go to change the temperature back to from 5 to 4, bring it down. We watch this sometime. Then we realize 1 degree may be okay, 1 degree rise, 2 degree may not be okay. Number two, we notice also it depends on what they're wearing. If they're wearing a jacket or all that, they would be more sensitive. They're not wearing. So we watch that as well. So we call a thing called comfort index. Comfort index is a function of temperature and what you're wearing. In the US, summertime, we keep the temperature low, maybe 18 in the office, inside. So we wear a jacket. That's the reason.
Yes, it's very cold in the US in the interior. Summertime.
But the reason. So we watch it. So now many companies are saying, no, take the jacket off, doesn't matter. We will keep you comfortable, but use less energy. That's the comfort index we deal with. That's important. Machine learning gives me that number. Also, I do this for lighting intensity. I have an office building where we have sunlight coming in, and if more sunlight comes, you dim the light automatically so that you're not extra lighting that is uncomfortable doing that. Now the question is, second part of the question, occupancy, how people react. We have monitored that, and this is dynamic. In other words, if we have a formula we apply, the formula says temperature so much at noon is done. But people may be wearing different clothing next day. There may be more people in the building than normal. It's possible. More people means building gets hotter. For air conditioning load, you need to run more air conditioning. We sense that information. We have a sensor for number of people in the building. And based on that information, we can change the temperature. Dynamic do that. And then the question is, as you have asked the second part, if in brand new building, how I do this. I go with some reference case, the brand new building, but we make adjustments as the building becomes occupied by people, by actions, and by other like outdoor conditions, more fresh air, all those are the wise building platform.
So you first start with the standard values and then change the application according to how people are actually reacting to it.
Correct.
Yeah. Okay, perfect. Thank you very much, Professor Rahman. I have one last general question for you, if I didn't ask too many questions already. So what do you think is the biggest challenge in terms of energy efficiency for all this smart building, smart grid, smart ecosystem? Can you name only one challenge, or are there too many, or maybe not too many challenges?
Biggest challenge is education. People don't know what they can do to help the situation. They don't know. So they don't do anything. So I, as an educator, my responsibility is to let people know if you reduce the heating by 1 degree centigrade, you can save so many tons of carbon dioxide going in the sky.
Exactly.
People understand that. CO2 goes in the sky, causes global warming, we got a problem in the long term. So I can easily change 1 degree C. I would not feel too cold in my office, but I don't know what does it mean. So that's the challenge. Educate people about the impact of their action on global warming.
Thank you very much, Professor Rahman. This has been a very informative discussion. And before we actually wrap up, I would like to ask if you have any closing remarks for us.
Well, we are talking about the Istanbul GT&D conference to be held in September 2021.
Mm-hmm.
I am very proud that this is happening. I've been talking about this for almost 2 years now.
Mm-hmm.
It has been very fruitful discussion with many people in Istanbul and other parts of the world. So I am very excited this is happening. I would hope we can get a large number of people attending. By the way, we do this T&D conference in the US every 2 years. We have never done this outside US, never. So this is first in Europe, first in Istanbul, the big.
We're very excited about this, actually.
So I'm very proud that people in Istanbul, ITU especially, have taken the lead, and they are delivering this. I am very supportive. I hope I'll be able to attend and speak at this conference September 2021.
Excellent. We're looking forward to seeing you at the conference. Hopefully, the pandemic will be over by then. And we'll get together face to face and enjoy this wonderful conference and exhibition. So thank you very much for both your collaboration with us and your support in this conference. I think we can wrap up right now. And thanks to our followers for watching this video with us. Maybe if they have any questions, they can share their questions with us, and then we can send them to you as well for further discussions. But for the time being, I'll thank you once more, and we'll hopefully see each other next year in the 2021 IEEE PES GT&D Istanbul Conference and Exhibition.
Thank you, Leila. Thank you very much for the nice interview.
You're welcome. Thank you.
Okay. Bye-bye.